Right now, Mercury, the closest planet to the Sun, is still shrinking, cracking its own surface open from the inside out, and NASA has no way to stop it. This isn't ancient history. The cliffs left behind look fresh, almost freshly torn. And what that means for a planet that was supposed to be geologically dead is something scientists are still afraid to say out loud. Mercury is small, barely bigger than our moon. A scorched gray ball of rock and iron closer to the sun than anything else we orbit. For decades, we thought we understood it completely. A dead world, no atmosphere to speak of, no weather, no motion, just a fossil frozen in place since the solar system's earliest days. Then in the 1970s, Mariner 10 flew past and photographed something strange. Cliffs, massive ones, cutting across craters like scars, some over a mile high, some hundreds of miles long. Scientists called them lobate scarps, wrinkles in Mercury's crust caused by the whole planet contracting, shrinking like a grape drying into a raisin. At first, this seemed like old news, a cooling core, a dying planet slowly deflating over billions of years. Case closed. But here's what nobody told you back then. Nobody actually knew when that shrinking had stopped, or if it had stopped at all. That question sat unanswered for over 30 years. Until NASA's Messenger spacecraft arrived at Mercury in 2011 and started mapping the planet in a way no one ever had before. What it found didn't close the case. It reopened it. Some of those cliffs, those ancient-looking scars, showed almost no erosion. No pileup of small craters on top of them, the kind that should build up over billions of years of space debris hammering the surface. Which meant one thing. These scarps weren't ancient at all. Geologically speaking, they were young. Some disturbingly young. And a young cliff on a supposedly dead planet means only one thing: something down there is still moving. Here is where it gets uncomfortable for the people who study this for a living. A planet doesn't get a small crust wrinkle from nothing. Mercury's contraction comes from its core, a massive iron core, disproportionately large for its size, making up nearly 85% of the planet's radius. As that core slowly cools, it contracts. And as it contracts, the rigid outer shell above it has nowhere to go. It buckles, it cracks, it thrusts upward into cliffs that stretch across the whole planet. The obvious explanation was that this process finished long ago, that Mercury cooled, shrank, and went still within its first billion years. But young scarps break that story completely. If the crust is still folding now, the core is still cooling now. Right now, while you're watching this. And a core that's still actively contracting means Mercury may still be tectonically alive, quietly, almost invisibly, but alive. Messenger found something else that made this harder to dismiss. Tiny fault scarps, some barely taller than a building, layered directly on top of very small, very fresh impact craters. Craters so small they get erased by space weathering within tens of millions of years. Not billions, millions. That's a blink cosmically speaking. It means whatever cracked that ground open did it recently. Possibly within the last 100 million years. Possibly, and this is the part researchers say carefully, almost reluctantly, possibly still happening today. If Mercury's crust is still shifting, then Mercury may be experiencing quakes. Right now. Not violent ones we'd feel standing on the surface, but slow, grinding slips along faults hundreds of miles long, as an entire planet continues to physically shrink beneath its own skin. Estimates suggest Mercury's radius has contracted by as much as 4 to 7 kilometers over its history. That is an entire planet pulling in on itself, like a fist slowly closing. And nobody, not NASA, not the scientists who spent a decade studying Messenger's data, can tell you exactly when it will stop, or if it ever will. This breaks the tidy version of planetary science we were taught. Small rocky planets are supposed to cool fast and die young, locking their geology in place within the solar system's infancy. Mercury was the proof of that rule. Now it might be the exception that unravels it. If a planet this small, this old, this supposedly dead, can still be quietly deforming under our feet, quakes rippling across a world nobody thought could feel anything anymore, then how confident should we really be about what geologically dead even means? Earth's core is cooling too. Every rocky world is. The clock we thought only applied to small, forgotten planets may be ticking under every planet, including our own. So Mercury sits there, silent, scorched, 300 million miles from Earth, closing its fist a little tighter, one imperceptible quake at a time. NASA has spacecraft that mapped it, none that can stop it or even tell us exactly what it's still doing right now. So the question is simple, and nobody has answered it. If a dead planet can still be shrinking, what else out there have we already given up on watching?